I want to talk about the best response curve. And so the idea behind the best response curve is that it comes from the employee. And so the employee is deciding, okay, based on this wage that I'm being offered, how much effort am I going to put in? But it's going to be important for the firm because the firm is choosing the wage. And so from the firm's perspective, we can think about it as a feasible frontier like we had in the earlier chapters where they're transforming a dollar of wage into amount of effort. Okay, so the slope of the best response curve is going to be like a marginal rate of transformation. So if we think about this, we don't really know how to measure effort, right? Effort goes from no effort at all to maximum effort. We're just going to call it from 0 to 1. And then we've got the hourly wage on the horizontal axis. And so at the reservation wage, right, in this is the case with the unemployment benefits, there's really no point in putting in any effort at all because you could just quit that job and collect your unemployment benefits, except of course in real life you can't really do that. But as the wage increases, you will increase your effort. And we're assuming it's concave. It's not a bad assumption. Of course, there's some sort of maximum effort that you'll probably never get to, but that's where the employee is making the choice. Okay, so keep in mind that we're drawing this for a given level of disutility of work, for a given level of unemployment, for a given level of unemployment benefits. All of that goes into the shape and size of the best response curve. And so at a wage of $12, right, we can say, all right, well, at a wage of $12, we go up to point J. We see that Maria is willing to put in half effort, 0.5, whatever that means. We know it's more than 0. We know it's less than 1. And there's some slope to her best response curve, which we are going to call the marginal rate of transformation. And you can see it's steeper at point J than it would be at point K, where at $24 an hour, she's willing to put in 0.8 effort. And really what the firm is trying to decide is where they want to put Maria's effort. Do they want to pay $12 and get 0.5 effort? Do they want to pay $24 and get 0.8 effort? Somewhere in between, somewhere higher? Because the amount of effort that Maria puts in is going to translate into the amount of output that she produces. So that's our feasible set. They're going to want to be obviously on the feasible frontier, on the edge at a point like J or K. They're not going to want to be inside, but they're going to try to choose one of those points in order to maximize their profit. So from the employer's point of view, they are choosing a wage, they're transferring into effort, effort's being transferred into production, production is being transferred into profit. And so the employer wants to choose the wage that will maximize his or her profit. So let's think about what that profit is, okay? So remember, profit is just revenue minus cost. In this case, we're going to assume that revenue is some function of the number of workers, that's capital N, multiplied by the effort per worker, E, right? Which is going to go from 0 to 1. So then profits are just the revenue minus costs, and we're ignoring all the costs except for labor costs, right? So we could say we could put in another number here, but it's actually not going to change the result. So profits then are some function of effective workers, N times E, minus the wage bill, N times W. Now we can divide that E, we can multiply it by W divided by W, which is just 1. And then we can see that for a given wage cost, NW, profits increase as effort increases. And so what we're going to want to try to figure out is the level of profit for each level of effort per wage. And so we're going to be able to graph it in the same space as the best response function. So how does that work? Well, basically what we're going to do is find all the combinations of wage and effort that give the firm the same level of profit. And so remember, same means ISO. ISO means same. And so an ISO profit curve is a curve where all the combination of inputs give the same profit. And the slope of that isoprofit curve we're going to call the marginal rate of substitution, right? How can we substitute wages for effort? So here's an example, right? If this was just linear, right? If the effort was linear, then at $10 an hour, if we're getting 0.45 effort, then that would give us the same output as paying $20 an hour and getting 0.9 effort. And so all the points along this line give us the same output at the same cost and therefore give us the same profit. Now, we're going to have lots of different profit curves, right? There's actually going to be an infinite amount of ISO profit curves. We're drawing 3 here. Now, the question is, all right, which do we get higher profit on? Well, at $10 an hour, we're getting 0.45 effort. Here, we'd be getting even higher effort, while on the bottom one, we'd be getting lower effort. So the ones closer to the left are higher profit, and the ones closer to the right are lower profit. So we can see, for instance, at point B, we only have to pay $10 an hour for 0.7 effort, whereas at point A, we have to pay $13 an hour for 0.6 effort. So obviously the firm would prefer to be at point B, but that's not up to them. That depends on the worker's best response function. So we have higher profits, medium profits, lower profits. Just keep in mind that there's a whole range of ISO profit curves. Now, if the slope of the ISO profit curve is equal to the marginal rate of substitution, and the slope of the best response curve is equal to the marginal rate of transformation, we're going to want to find the point where those two are equal. Right? And so that's what we're going to do. We're going to set the marginal rate of substitution equal to the marginal rate of transformation. And in almost all cases, this is going to give us a wage that is higher than the firm has to pay in order to get the worker. Right? So the way we thought about it before was, all right, well, if Maria's reservation wage is $6, they really only have to pay a little bit more than that to get her to accept the job. But on the other hand, she's not going to provide much effort. So they're going to want to provide a higher wage to get her to provide more effort, and that's what we call efficiency wages. Another benefit that firms get from paying efficiency wages is that workers are less likely to quit, so there's less turnover. They don't have to hire as many workers. So here's an example where we have the worker's best response curve, and we have our ISO profit curves, and our maximum profit is going to be at point A, right? We could be at point C, but at point C we're at a lower ISO profit curve. And so the firm would be getting lower profits. They don't want that. They want to be at point A. They'd love to be at point B, right? Point B is great, but the only way they're going to be able to be at point B is if the worker's best response curve changes. And so we're going to talk about that a little later, about what are some of the things that will change the worker's best response curve. So in this case, our medium profit ISO profit curve is the maximum feasible profits. They could be on the lower profit curve, but they wouldn't want to be. They'd like to be on the higher profit curve, but it's infeasible. So that's where we find this equilibrium. So we're going to stop there, and we'll talk about some of the ways that firms try to get on that higher profit curve in the next video.